All right, here we are, episode number 6. Last episode we did collision detection. We had the funny side effect of the bullet disappearing, but not the enemy that it was colliding with. That was kind of unexpected and entertaining, but we fixed that and talked about how we could have changed all of this up so that it will potentially add something like an explosion or something into the game when the enemies are destroyed. Again, I don't have any explosion animation right now, so we're not going to do anything with that just yet. One thing I did want to address, after the recording was done, I was watching it back just to make sure that everything looked okay for YouTube before I posted it. And I was looking at this code as I was going through and working it out, and I realized that although this works, it's not exactly the most efficient way to do it. And then the other thing that I realized was, during the stream I had mentioned that there was the potential problem of if the distances between the items was too large, the subtract would have the same problem that we had with the other algorithm. So if you remember, I had said, okay, if we have on the screen here, if the player is over here and the enemy is here and he fires the bullet, the subtraction that's going to occur there is going to create a problem potentially with the plus and minus, because the range of the byte is minus 127 to 128 positive, and that was going to be an issue. But watching it over again, I realized that I had done something kind of stupid. There was no reason to be doing the subtract with carry like this. And I think that was kind of a holdover from the original algorithm, where I was showing that we could do the subtraction, do the delta x and delta y, right? Get the difference of the x and y and do the absolute value, and then use the widths of the objects to determine if the bounding boxes had collided. I think it was a holdover from that, because you don't need to do that, and we'll fix this first, make this work again with the changes involved, and then we'll move on to implementing a more data-driven approach, like we had talked about in the last stream, where we're going to use data that's stored down here at the bottom of the code, where we had said, okay, there are 3 collision points, and here they are as offsets from the top left of the sprite. And I just wanted to mention that no sooner did I post the video than did somebody point that out on YouTube. So Sig Hewett, who had posted that comment, he brought up exactly the point I was thinking of, and that's why I had tweeted after I posted the video that I realized that it had that problem, that we didn't need to do that subtract. So thanks, Sig, for pointing that out, because you're exactly right, and we can fix this pretty easily, I think. Hopefully. All right, so what we need to do is, instead of doing the subtract like we're doing here, instead we just want to do a comparison. So let's see. So we're getting the bullet's X position, and we're setting the bullet's collision position by adding 1, and then we are storing that into collision. We're storing the collision temp into that, and then we're loading A with the leftmost position of the entity. Of this case, it's the flyby. Let me make that more clear. Get the leftmost position of the flyby and compare it with the current. Okay, so now that that's loaded into A, all we have to do is compare it to collision temp. So we don't need to do this anymore. And then what we wanted to see is the bullet's position greater than or equal to the X position? Is it greater than or equal to the left-hand side of the entity's X position, right? So sorry I keep harping on this, but I think it's just important that we kind of are clear, even though it's such a simple concept, right? So is this position here, is this greater than this line here? So when you do the comparison operator on a value, it's going to set the carry flag depending on the values stored. So if the carry flag is not set, so that would be branch carry clear, then the value is less than the value in A, so this X position is less than the collision temp, right? So in that case, it would be, it would potentially be, well, it would definitely be within the range. But the one thing we will probably want to do is maybe we want to reverse the comparison, because what we want to know is it within, basically, is it greater than or equal to the left-hand position of the sprite or the flyby? Because if it isn't, then we can just stop checking all the rest of the corners of the sprite, right? Because if that X position is somewhere over here in this space, then it's not going to collide. If it's over here somewhere, then there's obviously the possibility that it's going to collide, and we want to check that. So let's do this. Let's reverse the order that we're doing this so that we can keep the position of the bullet in A, and then the position of X will be in, the position of the flyby will be in collision temp. So that's into collision temp, right? We're loading the flyby's X position into collision temp, restoring that, yeah. Loading the bullet's current position, we don't, right, then we want to add 1 to A, and then we want to compare A with collision temp, and if A is greater than or equal to, I'm confusing myself here, so the bullet position is in A, right? Right, so the bullet position is greater than or equal to, so XB is greater than or equal to XF. That would mean that the carry bit is set, so branch carry set, no, so branch of carry clear to check collision point 2, right? Because if it's set, then we know we want to keep going, because it was the bullet's position is greater than or equal to the position in collision temp. Okay? So now, and the reason I'm hesitating when I do this is because I'm still mentally trying to I have it up on my other monitor. I'm still trying to kind of internalize what the clear and the clear of the carry, or the set of the carry, actually specifically means. So, all right, we know that the X value is now greater than the leftmost side of the flyby. So now we got to check the rightmost side. So we want to load a well, I don't want to mess with A. The other advantage of doing the compare is that, unlike the subtract, the compare does not change the value of A. So let's do this. Let's load X with the X position of the flyby. but if we need to add 8 to it, trying to think about what's the best way to do this. So we can shuffle some things around. Let's do that. Let's transfer A to Y. No, we can't do that because we're using Y. So the issue is I want to add 8 to the position to the X position, which is in collision temp, because I want to go comparing the X's from here to here. But maybe let's do the Y position first so that we can avoid having to do the math. If we find that the position is outside, less than here instead of being greater than or equal to, right? So then by doing that, we're saying, okay, let's narrow down the field that we're looking at so that if it's within this space here, we know it's not colliding. So now we're just checking to see, is it within here? So at least we know we're getting closer, and then we can sort out how we can shuffle the numbers around. It doesn't really affect the algorithm per se. So let's do that. So I'm going to load X with, but I can't do that because I'm using X2. So all right, so something's got to give. We gotta all right, I'm gonna bite. I'm gonna push A. I feel like that's and part. Oh, wait a minute, dummy. That's the thing about trying to stream this and talk about it at the same time as you're doing it, is that sometimes you just do stupid things. So I don't need to do that. I can just get the X position of the thing. Should be able to, no, that's not going to work either, I don't think. Just batting 1,000 here. Let's see. Can you do that? You can do it. You can do it. Okay, cool. Well, that's good. That's what I wanted to do. So instead of loading it into A and then storing it into collision temp, we load A with the position of the bullet. We then add 1 to it, and then we compare it against the flyby's X. Compare to flyby X, right? So that's all good. That's all simple. Same thing with the Y. We say, okay, A already has the bullet's X position. Oh, well, if we're doing that for Y, we gotta look. Okay, let's do that anyway. Load the Y position into A. We'll iron all of this out here in a second. The Y position is going to be also 1 greater. So, right, compare entities Y position with X. Right, so we're comparing it to the flyby's Y position. Same thing. If carry is clear, then we know that it hasn't. It's not going to. It's not going to be within that range because it would only be clear if it was less than. If it's greater than or equal to, carry will be set. So if that's the case, then we move the collision point. We if it's less than, we just jump to here and we skip to the next collision point, which obviously we didn't implement to save time. All right, so why do I feel like I'm just being dumb here? Probably because I am. So all I would need to do, yeah, I am being dumb. So really all I would need to do is, if it's, or I've already added 1 and I want to check the X position is 7, I add 6 to that position, compare it. So this is where we want to is this where we need to shuffle some things around? Because what I want to do is I want to and this may just simply be because I'm using these registers to index into the memory instead of storing the information in just a variable somewhere. But so be it. So we'll move the X position over to the right, and now I'm going to push A. I think that's the right, or is it PHA? It's PHA. I'm going to push A onto the stack. I'm going to load A with the flyby's Y position. No, the flyby's X position. I'm going to then add 8 to that because we want the right-hand corner of that, or the right-hand side of that, I should say. And then we're going to store A into collision temp, and then we're going to pull A. So now A is the value that we had before, where this is so right. And then this is xb plus equals 6, essentially. And then we're saying get flyby x of the flyby x of flyby plus equals 8. Right, we put it into there. Get xb back into A, compare with collision temp. Now let me think about if that makes sense too, to do that collision in that direction. So in this case, what we want to do is we want to check to see if the bullet is now, I wish my keyboard wouldn't do this, there's something funky going on with that. So come on. So if now we want to check, is the bullet X position less than or equal to the right hand corner? So realistically, yeah, that's fine. So compare collision temp. All right, so if A, which is the bullet position, is less than the right hand side of the flyby, then the carry flag will be 0. So what we want to do is we want to check if it's equal, because if it's equal, we don't want to, right, if it's equal, we don't want to check, we don't care if carry is set, right? We only care if carry is set if it's not equal. So something like this, I guess, right? So if it's equal, that means it could be greater. It could be that are xf and xb equal, right? They could be equal, or it could be that xf is greater than xb. No, sorry, xb is greater than xf, right? Because we're comparing here, we're saying xb, we're looking to see is it less than or equal to xf, and xb is in the A. So right. So okay. So if it's equal, we're going to skip over the next check because we're okay with it being equal. But if carry is set, then we know, if carry is set but it's not equal, then we know that it is in fact only greater than and not greater than or equal to, if I'm reading this correctly. Just give me a second here to look at this one more time. Yeah. Yep. Okay. And this is actually okay. Right. Yeah, you really learn to appreciate higher level languages when you have to write an assembly to do something this simple. DGMTV, having so little register calls for some clever tricks to have fast code when needed. Yep, that's totally true. All right, so we've got the collision point 2 call there, which means okay, we know at this point that we're in the X range, right? So that's cool. That's what we wanted to check first. So now we want to load A with the Y position of the bullet. Same thing. We want to add to it, but in this case we want to add 4 because if you remember from last time, we're checking for this position, excuse me, this position here. So, all right. So we add that there in A. That looks good. And now we just want to do a compare with the Y position of the entity. And we want to check if we are... So in this case, we're checking the bullet's position against the flybys, right? And same thing here, right? If the carry is clear, then we are less than the Y position, which means that we're outside of the bounds of. Come on, keyboard, Alt Tab for me. We're outside of the bounds of this area here. So check collision point 2. And then same deal here. Actually, wait a minute. I did something stupid. I knew this seemed wrong. I was... Again, this is why like streaming is so difficult, because you're trying to explain what you're doing at the same time as you're doing it, and then you inevitably kind of lose your train of thought because you've spent so much time explaining what you're doing. We don't need to add the X, we don't need to increment the X position of the collision point yet, because we are not doing that check yet. We're still on this collision point here, which is on the left. So that was unnecessary. This push is still fine. It loads the position. It does the... That's all good. We're storing it. We're pulling. We're comparing. That's all good. Okay. Sorry. All right. So getting back to this for a second. So we've got our Y position. We check it against the Y position of the flyby. If we're less than the flyby's Y position, we know we're outside of the possible bounding box. So we can just skip past the next set of checks. The next thing we want to do is we want to, again, push A. We want to load it with the Y position of the flyby, and then we want to add 8 to it so that we're now checking the bottom part of the bounding box. And then we want to store that into collision temp, and then we're going to pull A, and then we're going to compare it again. Same deal as above. If it's equal, we go to skip Y, right? Because we want to check to see if it's less than or equal to. So we got to check first the equal condition. If that's set, then we're good to continue on. If it's not set, then we have to check the carry flag. So branch of carry is set to check collision point 2. Here's skip Y. And then we're done. So that actually seems a lot more straightforward, assuming that it's actually working the way it's supposed to. At this point, this condition is still true. We know that the X and Y are both within the bounds of the flyby box. We load the entity, store that it's no entity, finished. Okay. That looks good, or pretty reasonable anyway. Let's see if it's broken. Yeah, reload the file. Great. Okay. So I finally got controller working through USB instead of through Bluetooth, since that kept messing things up. All right. So there's our flyby. We're not getting any unexpected behavior with it disappearing because of a errant bullet. That's good. That all looks very good. Great. All right, so that's looking much better. Okay. Any questions on this before I move on to doing this with the data in the array or further down in the cartridge? What does this say? Kudos to you. One of my downfalls is coding and explaining at the same time. I'm always going back and finding an easier solution. People just get confused. You're doing great. Well, thanks, Terrorisk. Appreciate it. All right, I don't see any questions right now. So I'm gonna keep going. Oh, you know what? I never took down this banner. I gotta make that a little more automated so I don't have to remember to do that and have that across my stream for half the stream. All right, cool. So that's good. That's what we wanted it to do. I think to start off with, so like all of this that we've done here, right? This is pretty hard-coded, and we're going to change the way it works so that instead of it being hard-coded for each of the different collision points on the entity, we're going to make that each of these points be data in the game that gets loaded for this specific type for the bullet, and then used to compare against the bounding box. Now, even the bounding box itself could potentially be turned into a data set. I don't know if we want to do that tonight, or there was another thing I was thinking about doing tonight about the way that the ship moves. One of the things that I noticed that the ship is very like stiff. You know, it doesn't feel like it has any momentum to the movement. It just kind of, you know, stops when you stop, and it goes when you hit the keypad. And I feel like it would be cool to make it feel a little bit more realistic the way it moves. So you can tell me what you think in the comment in the chat area if you want to see one or the other. Otherwise, I'll choose. But let's make this work with at least the collision points right now. All right, so the way that this needs to work is we need to know. So we need to know how many collision points we're going to be comparing against, right? And that's what this is. We need to potentially change up how we're handling all of this stuff with the way we're accessing the memory, because right now we're using these registers to index into the memory here. And while that works okay, let's see, thinking about this for a minute here. Each time we loop through, we're going to take the position of the X and Y of the bullet and offset it by the data that's in that table down at the bottom. And the flyby functionality is essentially going to be the same. I'm thinking probably could generalize this into a few variables that we use, right? So something like, I'll leave this for now, but the collision temp, we may still need it, but something like bounding X, bounding Y. And we could even pre-compute, right? We could say left, bounding top, bounding right, bounding bottom. And I mean, it's 4 bytes, but we could pre-compute instead of having to do some juggling with things, just kind of pre-compute what the bounding box looks like. And then would that be, maybe we wouldn't need to do that for all 4 points. I mean, it's pretty simple stuff, so I don't know that it really causes any harm. Let's take it one step at a time here before we start trying to optimize things. Let's just get it working with this lookup approach, and then we can start to optimize things if we need to. All right, so we're going to compare if it's a flyby, and if it's not a flyby, then we go to check bullet entity finished, which means that if we fall into here, this is a flyby. I mean, realistically, we could do something where, you know, all of the types that are enemies have one of the bits set in the entity type, so that we just, it doesn't matter what it is, we just apply logic to the entity that says, you know, you're an enemy, so you're hit, and then the behavior is different depending on the enemy. And we can generalize how this works for the flyby, away from the flyby, but into something that's good for any enemy with just a standard bounding box. But again, let's just get this working as is. I'm just kind of thinking ahead, which is probably what's, screwing me up sometimes. So this is a flyby. So let's start with computing those corners. So load a entity, entities, store a into collision left, load a y position x, store a collision top. We can, what we can do, we can be a little smart about this and say add carry 8 and store that into collision right, so that we don't have to reload. Because if we did it the way I was about to do it, we load the x, we load the y, then we load the x again and do the add, and then we load the y again and do the add. This way we just load the x and store the left position, and then we add the 8 pixels and store the collision right value. Same thing here, we store the y into collision top, and then we clear and add the carry to 8, and then we store it into collision bottom. So we saved a little bit of work there by not having to reload those values twice. Okay, so that's that. We have our collision. And then we want to get our collision points for the what's it called? For the bullet. So at this point, what I'd like to be able to do is I'd like to be able to iterate through all of the collision points and compare it against those collision variables. So think about how I would do that. So I want to compare that against, actually instead of storing that as a byte down here, where is that? I think it's better to make it a constant. Come on. Right, is that how you define the constants? I'm still remembering how all that you just do. Right, so we have a constant so that we can compare against that directly instead of, yeah, that'll be okay. Will it be okay? No, because that works fine here, but the problem is that if we want to generalize this, what we really want to do is do something like bullet collision right. So what we're doing is we're laying out effectively, if you think about, so when you used to, I mean, this is not anything I invented, but this is how I'm thinking about it. So when I used to write stuff in C and C++ where we were storing data in a binary format, you used to define your data in structs essentially. You'd have in C you'd do something like struct, call it collision points, right? And type def struct collision points, collision point, right? And that's your struct, and then you'd say, okay, point count, or in this case it's a single byte, so unsigned character, so one byte, point count. And then what you'd generally do, because you wanted it to be Well, I mean, you could do a couple of things. I mean, generally you would potentially have something like a pointer here, X points, Y points, and when you were serializing your data to memory, to a file, you knew that this was a pointer, so you couldn't write everything out. But like what I was getting at is that, you know, you could envision that you have this as just a data structure that is 3 points that are single bytes. It's the same idea, right? That's all we're doing here, except we're doing this handwritten into the assembler. The assembler is writing it out onto what would essentially be the cartridge. So you'd make these pointers just because you could have an arbitrary number of points up to 255, and when you wrote this out, you wouldn't want to necessarily write out 255 points for the entire file. You'd want to write out just the number of points you actually have. So what I'm thinking is same idea, right? Is the first thing we're going to read from this location is we're going to read the first byte, which says how many points we have. And this can be generalized for any type of entity that we want to do point-based collision, right? So the idea is that what you're giving it is you're giving it the address and memory of where that data lives, and then it just does the same thing for all the data that you have in your game. So while what I was doing would work, what I really want to do is something like this. Load a what did I call it? Bullet collision. Right, bullet collision, and that's going to load. Is that going to load the? I think that's just going to. That will try to load the value. You know, we'll find out in a minute what it does. I'm pretty sure that'll load the value of the first byte there. And I could do something like +1 to get the second byte. I can't recall 100%, but we'll see. That should be right. Okay, so now the next thing is we need our iterator to be able to loop through the different collision points. Well, actually, so that should be okay, right? So I want to, right? So I don't need to load that into A. What I really want to do is I want to compare. Let's say we're going to use X to iterate through the collision points. Keep messing up the name of that. Bullet collision, right? So compare X bullet collision branch if equal to check bullet entity finished, right? Because at that point, if bullet collision is equal to the value of X, we've hit the maximum number of points we want to check, and then we're good. We're done there. And then it's going to continue on to the next entity. All right. So we were using X to find the entity that we were looking at. So we do need to save the X value in order to make sure that we can come back to the loop. So transfer X to A, push that onto the stack. And then what we'll do is at the end, when we're done, we will pull A, transfer X to A, transfer A to X. We don't need to do this anymore because A will already have that value from when we pulled it. And then we're gonna jump, yeah, okay, that looks good. I feel like we might be doing some unnecessarily juggling, but that's okay. We'll get to that, and we'll get to that when we're done here. So compare that, and then branch if equal right. All right, so now we have our index that we're going to use to find the offsets for the position that we're checking against of the collision point. So what we want to do is we want to load okay, yes, we want to get the bullet's position's current X, and then can you do an add carry with position of memory? I don't remember. Yes, you can. So that's good, because what we want to do is we want to, so we have A, and then we're going to clear the carry. We're going to add the carry to and again, this is still kind of hard-coded a little bit because in theory we could change this bullet collision label to be a pointer, essentially, in memory, where we've stored the address of bullet collision into a location in memory that we're using to then do the comparison and also do the add and the index offset in memory. But let's get it working this way first before we further complicate it by introducing the pointers. So we've added it with that. So now we've got our X offset set up properly. Get the let's collision position XB, right? That's what we're doing. That's good. All right. So then we don't need to compare it to this. What we want to do is we want to compare it to collision left, which now has what that value used to be, essentially. Yeah, so let's do this. Let's collision left. Okay. So we've got that there. And then this logic is the same, right? We want to make sure that that's all good. Then we're going to push A. And then we want to get the right position, but we have that already, so we don't need to do that here. Yeah, so actually that's the nice thing. We don't have to do any of this anymore because we have the right side already, and A already has the value of the X collision point that we want to check against, so we just want to check collision right. Let's just say for clarity, right? And then same check as before. We say, okay, if it's equal, then we don't have to check the carry because we know that it's okay. But if it's not equal, we want to check the carry to see if it's less than or greater than or equal to. So okay, good. So that's what I was looking for there. And then same thing here. So we're going to load the Y position of the bullet. Instead of doing this add with carry on this, we're going to do an add with carry of bullet collision Y with X, right? Because that's going to give us, get the bullets Y collision position YB, right? And then we're going to compare this against collision top. And that's the same. And then we don't have to do any of this. because we've already got the bottom value. Bottom. I spelled collision wrong here. Okay. So we got our comparison here. We're going to do the same thing, branch if equal. Otherwise, we're going to check the carry flag. And if we are in here, then we know that we are good. And we are going to, okay, so now this is a little bit of a tricky bit here, right? We know that, okay, so just a slight change, because we need to know what the value of x was for the entity in order to store the no entity type properly. So what we want to do here is we want to pull A and transfer A to X, get the entity index back from the stack. And what we don't want to do is we don't want to pull and transfer here at the end of the loop, because if it was successful, we've already done that. If it wasn't successful, we can do that here. We can call this check collision point failed. Right. Oh, it messed up all my alignment. It's funny how aggravating that can be over something silly. I'm gonna probably have to add a little more white space just to make these comments readable again. So that's all good for one point, but we still have to do a couple points. Right, we have to do all the points. So we actually don't want to do that here. What we want to do here is we want to increment x and then jump back to collision point loop. Right, and then this should actually be check let's see. Oh, that's true. We're not going to check against any more entities because we're good there. Okay, well that actually simplifies things then. Because if we've so if we've cycled through all the collision points, all the collision point offsets, then yeah, if we've cycled through all the collision point offsets, then every time we're going to end up here at collision point failed, and then we're going to increment x and jump until we get to the point where this compare is successful, at which point we're going to branch down to here, which means we're going to pull off the stack and transfer A to X, which gives us back our entity index. And then we're going to go to the next entity in the loop. So what we want to do is, let's see, is that right? Because then if we make it all the way to the bottom here, then actually we don't even, well, we don't care about No, we do care about X, right. Okay, right. We need to get the entity index back from the stack in order to change it so that there's so that both the entity and the bullet get destroyed. Now, if we did have the scenario like we talked about last time where we would want the bullet to destroy multiple enemies, at that point we would have to push the X index back onto the stack, because at the next, once we jumped over, well, we could probably shortcut that and make it so that we didn't have to do that. Never mind, that would be fine. We would be able to do that without pushing and pulling it back off. All right, so let's just add a. No, why are you doing that? It's weird. Sublime Text sometimes tries to auto complete these instructions, and I feel like it's definitely messing things up, because like that should have been, or is that just user error? No, yeah, see, it should have been transfer A to X, because we want it to have the index back. So get the entity index back from the stack. Clear carry, add size of, transfer A to X, jump back to here, where here is check bullet collision loop. We're here, we check against total entities. If it is the number of total entities, then we're good. This should be, I guess, this, because it's not an address. Right, so if we've hit total entities, then otherwise we check the type, and if the type is a flyby, we go through the whole thing. We set the left, the right, the top, the bottom, and we push X onto the stack, and we do this all again. So that's pretty cool. That looks good. It didn't assemble, but that's okay. 521. What did I name these? Oh. I don't know which is better. Collision left, bounding left. I think bounding left is probably better. No, not search, replace, please. Yes, yes. That's that. Love to know why my keyboard keeps doing that. Collision top. Did I miss one? 540. Yep. Bounding top. Replace. Good. Misspelled that. Oh, good. I did it in a couple places. Bounding. Symbol bounding bottom is undefined. Oh, I misspelled it here too. Range error. The dreaded range error. So range error is I'm asking it to get something that's too far away. it's too many bytes away for it to pull it over for me to do what I'm looking to do. So let's see if we can get by without doing too much. Is that really what the problem is? Thought that's what the problem was, but let's do some collective Googling, shall we? I'm pretty sure that it's because it's too far away. Referring to a global symbol from inside the scope or proc. Is it because is it because I'm doing this? Well, it worked fine with the palette, so I'm just doing something dumb. What am I doing wrong? Is it because there's nothing in there? If I just do this, no. Load a palette X. Okay. Let's go 211. We'll get to what it looks like when it's running in a second. So bullet collision. Where is that? I think it. Okay. No. Yeah. That was just me. Okay, we can use collision temp for that. Let's do that. Here X pound bullet collision. All right, so let's load a with bullet collision. Oh, you know, this is good because this made me realize I also never loaded X with a 0 index, so that would be helpful. Otherwise, we're going to start from whatever the value of X is at the time. That's no good. Load A that, and then store A into collision temp. Found a use for you. After all, collision temp. All right, so bullet collision is X. Okay, offset 0, which is what we wanted anyway. Okay. So let's see if this is totally broken. Yep. All right, so I just tried to fire a bullet and it's stuck in a loop. So let's see what we broke. So do I still have those no ops? I do. Okay, so I still have those no ops to make it easier to find that code. So I'm sure, oops, I did not want to modify the program counter. Let's try that again. Let's reset. Go to the debugger. So go to the beginning of our assembly. Look for those no ops because that's where our code is going to live right after that. There they are. And we'll just walk through this. We'll step right through it. As soon as I hit the A button, it's going to fire a bullet and go into the collision detection routine. So, all right, so X has a 0 value. And we're going to compare it against the total number of entities that you can have, which obviously it hasn't reached because this is the first time through. We're going to branch if equal, which it's not. We're going to load A 17x. So let's follow along with the code here since we have the comments. So we're going to load. Let's see, it was doing the branch with equals. Okay, so we're going to load the type of the entity, and we're going to compare it to see if it's a flyby. which is, where is it? Which is 3, right? So we're going to step over. We're going to branch if it's not equal. Okay. So, okay. That's the problem. So the problem is that when the compare, or at least one of the problem is that we're comparing the type against the, where is that? We're comparing the type against the flyby type value, and if it's not equal, we're going to go to bullet entity finished, right? The problem is that bullet entity finished is now pulling off the stack, which we don't want it to do, because bullet entity finished in this particular case is pulling something off that it shouldn't be. We've not pushed X onto the stack yet, because that's only done in the positive case of identifying a flyby. So what we really want to do is we want to do something like this. We want to let me just think about this for a second. If this gets messed up in any way, we need A to have the value of X in it, and we don't, because I was being smart about it here, but realistically what we want to do call this skip entity, right? Because we're skipping the entity in memory, because we know it's not something we're supposed to be looking at for this particular type of entity, a bullet collision check. And so we are now, we don't need to do the pull, but just in case we didn't do it in the first place, we still have to transfer X to A. I mean, it's a wasted cycle, especially in this case, because we're doing we're pulling the value of X off the stack, which then we transfer to X. So A already has the value of X in it when we come out of this branch of the code. Trying to think if there's some way we can get around that. I mean, we could. Let's see. Might be not worth it for the amount of work we have to do. I mean, we could branch on the opposite condition and then have it set the value of A, and I mean, either way, yeah, it's not worth it. And just keep it like that, and just say setting A to the value of X, because we may not always have just pulled it off the stack. Pulled X off the stack. All right, so that should fix that particular problem, because if the entity type is not a flyby, we branch if not equal, so we then swap the index over from X to A, where we then add the size of entity, then we transfer it back to X. I feel reasonably okay with that. Right, skip entity is already defined. Let's call this collision skip entity. And then what we need to do, that reminded me, is we need to skip to collision skip entity. Actually, we'll be more specific than that. Bullet collision skip entity, because we may have other collision loops that we do, maybe not, I don't know. All right, so we can close that because that's broken. Hopefully it won't hang when we fire a bullet. Okay, that's a positive step. So now, there's the bad guy. All right, that actually worked. Does it work with the different collision points I missed? It does appear to work with all of the collision points of the bullet. Given how that's working, I'm feeling that that's actually probably pretty solid. All right, that's cool. Nice. So now that we have that, similar to what we did with the way that we moved the code to calculate the collision points for the bullet out of this and into a loop where we load up each point based on an offset from the origin of the sprite, which is the top left corner. We could do a similar thing, right? We have a similar thing for bounding boxes where we say, okay, if you know, for the flyby sprite, what we would want to say is we want to say, okay, from the origin, yeah, same situation. We would want to have two arrays that tell you the offsets of the bounding box. This would be the X one, and then this is the Y one. And then you could imagine where if we needed something rectangular, it could be 0 and 20, for example. And, you know, for Y, it's, you know, 0 and 8 still, right? Anybody have any questions for what we've done so far and how that's all working? That seems like that's working the way that I want. And like I said before, I basically want to do one of two things. But if we, you know, we might have we have two things we could do. We could make it so that the ship seems like it has some momentum when it's moving, instead of it just being very direct tied to the D-pad, which is kind of boring and doesn't really feel very much like you're flying through space. We could add some sort of physics to it where, you know, you almost have like acceleration or you know, some sort of feeling of momentum to the way that the ship moves, so that it's not quite so sudden, right? You want it to kind of have a nice little bit of a slowdown before it stops. Not that it's moving that quickly that, I mean, how much am I moving it if the D-pad is pressed? I think it's only maybe 2 pixels. Let's see. Not even, it's using only 1 pixel, so that might be actually tough to do. Might be tough to do with just the 1 pixel. We could make it so it doesn't stop immediately after you let go. It has a little bit of a slide. Terrorist, you're saying floating feel. Yeah, I mean, it's definitely more interesting in some ways to do those kinds of changes because, you know, it's more visual instead of just staring at code. So, yeah, let's do that. Let's do something where we kind of give it more of the after you, yeah. Let's give it a little bit of a more loose feel to how it is right now. So for the entities, we have this data byte. Right now, the way that we're doing the motion is we're literally just changing the X position and the Y position of the entity for the ship. We could do something like adding to velocity, right, to kind of simulate like what a real ship would do if it had some sort of thruster or booster, you know, that, I mean, obviously it's not realistic at all, but if you envision the ship, it's this wedge shape, right? When you move it through space, ostensibly it's got to have some sort of little booster here on this side that's going to move it in that direction. And of course it's got to have the same thing over here, and then would have that for forward motion, and all of that would contribute to the velocity. That would be an increase in that would be acceleration, really, and it would increase the velocity of the ship. And then when you let go of the D-pad, instead of just immediately stopping the increment that it's doing or the decrement that it's doing to the X or Y position, it could adjust your velocity by deaccelerating the ship until the point where it stops. So what I'm wondering is, maybe we'll add another byte here, or maybe we'll just add velocity as a thing that every item actually has. Sorry, I'm just reading this comment from Cisco 211. Basically, I don't understand anything you're coding here, but it's nice to see that the coding workflow is very much the same in higher languages. So, I mean, Cisco, you know, we can when I'm done doing the motion, we can talk about what it is you're not clear on. I mean, it might just be that you're not clear on looking at code and assembly. I had talked on one of the earlier streams about the idea of circling back on maybe a separate stream from the normal one, still here, but not on one of the Monday or Thursday days, going back and covering assembly and how it relates to the NES and maybe even to higher level languages. We could do some stuff where we take higher level languages and essentially translate it. We could be the compiler and translate it to NES code, and you know, if that helps. I'm not sure what your experience level is, so you know, let me know in the chat what you're thinking of, and we'll work on this, and we can circle back on that. So let's do this. This will be the we'll call it the XV, the X velocity, and the Y velocity. I'm having a lovely time typing tonight. Okay, so before we do anything here, if you remember from one of the earlier streams, if you've watched it, I had a problem where changing the size caused it to crap out on me. So let's just make sure that that's not the case anymore, that we fix those bugs. All right, so that's looking good. That's still looking good. And that's still looking good. All right, I feel happy about that. If we go to hex editor and look at the memory, yeah, so our entities are looking good. We're not seeing, if I just keep firing bullets and creating bad guys until we hit the limit, yeah, that's looking pretty good. You know, we could also, at some point, we should probably within the next stream fix the fact that it's fix the fact that you have that the player doesn't die when he gets hit by, or she gets hit by the ship, by the flybys, by enemies. That would be good to fix too. All right, let's do this though, because it'll be simpler, and then we'll wrap up for tonight with any questions or anything anybody's got. So basically, with the velocity, what we want to do is we want to make it so that when we hit the gamepad, what we're doing is, rather than modifying the X position and the Y position directly, we're instead changing the velocity. and vice versa. If we, well, not vice versa, but in the game loop, we should then also be removing or decrementing the velocity because we're going to simulate some sort of friction so that the ship doesn't just keep moving off to one direction or the other. Actually, as it is right now, what happens if you go off the side is it's kind of like if you ever played Asteroids on the Atari or the arcade, and just it rolls over the side. We probably want to fix that at some point, but that's not that important. The main thing is to let's get this whole velocity thing going, and then we can deal with that also. I'll put that on my list of things. I've got a list of items that I want to cover for each stream. So all right, so let's see. So those are the controller checks. We're doing this. So instead of adding to, so instead of decrementing the X position, what I want to do is I want to decrement the X velocity. That's what I called it, right? Or did I call it velocity X? X velocity. Okay. And then same thing. I want to increase the X velocity. And then I want to increase the Y velocity. And I want to decrease the Y velocity. I want to increase the Y velocity. Now, the thing with this is that we don't want it to be linear, it shouldn't be. We have to essentially figure out what our scale is, right? We need to figure out, and the more as I'm thinking about this may be, we may have to have 4 velocity directions. Well, it depends on what our scale is. Let me start with explaining what I mean, and then we'll go back. So when we're doing this, right? Well, actually, that's supposed to be my awesome representation of the ship. So let's say that's the ship. So we don't want it to be a one-to-one thing. We're applying acceleration essentially to the ship, which increases the velocity in one particular direction. So for example, it's increasing it in the X direction here, or it could be potentially decreasing the X position based on the velocity here. But we want to do that in a way that feels a little bit more smooth than just one-to-one. We don't want the one velocity, one Vx to translate to 1 pixel necessarily. We want it to be relatively slower, so that conversely, when we let go of the control, there's a little bit of slide before the ship comes to rest. And so there are 2 things. One is that if we want the velocity to represent the positive and negative velocity in a given direction in the axis, in the X or Y axis, then we're limited to that the old faithful 127 to 128, right? Which is fine. I don't expect that we would want too much velocity anyway, or too much acceleration anyway. I guess the question then becomes a couple of things. What is our scale, right? So what does it look like in terms of how does this map to pixels? How are we gonna translate that? Are we gonna say that, we could do something simple by just dividing it by 4, and if we divide by 4, then the maximum number of pixels we can get is 32. And then obviously we want to just make sure that we never exceed 128 or minus 127. And divided by 4, the reason I chose that is because you can do a really simple shift operation to do division by powers of 2. You just shift right, and it's not exact. It's not like floating point or anything, but it's good enough for what we're trying to do. All right, so let's do this. Let's say that that's okay. We're not doing any bounds checking. We probably should. Well, you know what? Let's just make this kind of work first, and then we'll worry about doing the bounds checking. So let's see. Where's game loop? So there's game loop. All right. So we're going to process the entity, the ship. Where did that go? Okay. That's the collision. Why am I having... Right, there's the jump. Here's the... Okay, sorry. That was weird. Process entity loop. So right now we're not doing any processing for the ship, because before we were directly modifying the X and Y position when you press the D-pad. So let's do this. Let's... I think it's player type. Yeah, I don't know why I included the word type there. Any type player. Okay. Branch of equal to process player, right? Process player. Cool. And then jump clear entity. No. Jump entity complete. We don't want to clear the entity because we're not destroying it here. All right. So process player. So what do we want to do? So like I said, we want to take that X velocity. And I think I know what's going to happen when we do this, but let's do it anyway. Just because I don't know for sure, and that'll be the easiest way to find out. So I'm going to load into A. I'm going to load the entity's X velocity. Right? And then I'm going to look at my cheat sheet here for... Oh, I have it open already. I believe it's just shift. ASL is for arithmetic shift left. What is it? No, is it rotate right? There's rotate right. The carry position is set. I don't care about the carry position in this particular case. Logical shift right. Shift solver right when position 1 is shifted into... Okay, I don't want that because I don't want it to shift around to the other side of the byte. What I do want... Okay, the carry is shifted into bit 0. Well, that's for rotate. The carry is shifted into bit 7, and the original bit is shifted into the carry. All right, so we want to... Okay, that's fine. That'll work. So clear the carry. I want to rotate right. So what we're doing here... Oh, come on. So what we're doing here is X velocity divide by 4, right? If you're familiar with C, it's the same thing as doing... Well, no, I'm not doing it by 4. I'm doing it by 1. What I want to do is I want to do it by 4. I want to divide by 4, which is not to do 4 shifts. It's 2 shifts. Right, so I'm going to if I clear the carry and I shift, bit 0 is okay. So I gotta. Okay, so we've done it here. So that's effectively the same as dividing by 4, right? Because let's stop and talk about that for a second. If you've never done bit shifting before, if you take the number like 10 in binary, right, and that's 10 because you have 1, 2, 4, 8. In these are the places, just like in the decimal number system. If you have 51, this is the ones place, this is the tens place, so it's 5 times 10 plus 1 is equal to 51, right? So in binary, it's the same thing. You have your 2 and your 8, so you get, in decimal, you get 10. Or this is equal to decimal 10. So if I were to, this is a bad number because it's not divisible by 4. Let's take the number 20, right? So this is 16. So let's, the number 20, well, that's actually a good way to demonstrate it. So here, we'll demonstrate what shift right and shift left do. So the number 10, I was saying that's not a good example because it's not divisible by 4, and that's what I want to do and demonstrate. What I do want to show you is doing that for 20, because 20 is divisible by 4. I was just going to draw 20, but then I realized, oh, okay, well 20 is actually a power, is just twice the value of 10, right? I mean 10 times 2 is 20. Because it's a power of 2, because all you're doing is multiplying by 2 in binary, all you have to do is shift the bits over by 1 place. So this becomes 1, this becomes 0, 0, this becomes 1, this becomes 0, and that stays 0 because it's just bringing a 0 in to from, in the case of the 6502, it's going to bring it in from the carry flag, which we would have cleared to do that multiply. So we've shifted the bits over by 1, which effectively multiplies the number by 2, because if you look, it's 16 plus 4 is 20. It's the same thing as by doing this in the decimal system, by the way, right? If you think about it, if you shift all the numbers over and add a 0, it's the same thing as multiplying by 10. The trick works exactly the same in the decimal number system as it does in the binary system. If you shift over, you are effectively multiplying by the base of your number system, right? So if it were 16, by shifting over, you're multiplying by the value 16 in hex, right? So what I was saying is that dividing by 4 is effectively the same thing as shifting over to the right twice, right? So if this is the value 20, I shift over twice, well, we already saw that by shifting over to the left once, we got the value of 10, so we're back to 10, right? And then if we shift over one more time, we have 1, 0, 1, right? Because the 0 that was here got shifted off. We have 1, 0, 1, which is 5. So we've divided 20 by 4 by just shifting the bits over twice. That's exactly what we're doing in this case too. Now, like I said, this isn't a perfect division because this is just shifting the bits off, so you're losing precision. There's no floating point part here, which, you know, if you took a number like 5 and you divide by 2, you're not going to get 2.5. You're going to get 2, which is fine sometimes, right? Like, you know, depending on what you're doing, it's not a big deal if you're truncating that decimal part of the number. In this case, we don't care because we just want something that's pretty fast to do. And then what we're going to do is, now that we've got that value, I want to add it to, I want to add the player's X position with that value. So So load A, no, add carry, entities, entity, X position. What did I do? I'm not doing that right. That should be a plus. And that's the X position, and that's comma X. Right, so now we've got that here, and then we're going to store A back into here, because we're done. We're good with that. And we can do that with X and Y. I imagine that this is going to be something of a hot mess, but we'll see. Y velocity. And then what I also want to do is I want to decrement the velocity, right? We want to apply essentially friction to the velocity to slow the ship back down if the player is not pressing the control. So that's just a matter of, we'll just do a straight up decrement. Oops, that's not what I wanted to do. We'll just do a straight up decrement of the Y velocity and the X velocity. And again, this is not going to work. This is not going to work for the velocity the way I want it to, because we don't know if it's positive. Well, we could test. Let's try that. Let's see if we can anticipate this and actually do what we need to. So after we do the add carry, if it's positive, let's do process player remove V, and then if it's negative, then we have to add. So if it's negative, if it's a negative velocity, we want to increase the velocity towards 0, right? And then probably before we do that, it's already there. All right, so before we do that, we also probably, oh, we can't do that. Okay. We got to do two things. First, we got to store this regardless of what we do with the velocity. And then I was thinking we didn't have to load A with the velocity again, but we do because we're adding. So let's see. So we're loading A with the velocity, and then branch of not equal to process player xv done. Right. So process player xv done. We're done processing the x velocity. And we were checking to see if it was positive, because if it's positive, then we want to remove. So we want to remove velocity. So jump to process player xv done here, because we're done dealing with that. Otherwise, we have process player remove xv, and we're going to load A. And if it is, so we're doing this branch of not equal to see if the value is 0, because if the value is 0, we don't want to keep removing or adding to the velocity, because then it's not going to stop moving the ship again, or at all. So that's no good. We only want to process the velocity. We only want to change the velocity if the value is a non-zero value. So if it's not equal, it's equal, then we're done with it. Could probably even do that. We probably have to do that over here anyway. Yeah, we have to do that anyway over here. So that's fine. So, okay, so we had to do that here because we wanted to check the velocity value if it was positive or negative, not the x position value if it was positive or negative. So we get the x velocity. We, if it's equal because it's 0, then we process xv is done. Process player xv is done. If it's positive, we want to remove. Otherwise, we're going to increment it. And then, yeah, so there's the remove. So we're going to decrement it. Obi-Wan Tap TV, what language is this? This is 6502 assembly language. This is the native language of the CPU of the Nintendo Entertainment System. And also the Commodore 64, the Apple II. There are a bunch of systems that run that CPU. And then, here we go, jump process player XV done. Let's see what happened with the X. 453. Yep, that usually helps. Okay, so let's see if the ship has any sort of more laggy motion to it. Nothing. Okay, so what's probably happening is we're probably not adding, we're not adding enough to the X velocity because we're also then removing it on the subsequent call through the game loop. So we need to add it faster than we're removing it in order for this to work. So let's do that. I'm just gonna be lazy and increment or decrement twice like that. Alright, so still not doing anything. Let's take a look at the hex editor and see if we're even getting updates to the value. Let's see. I assume that these are the values of, so these are the values of, I think there's a way to turn on for the controller. I thought there was a way to turn on so you can see what's being pressed. So you guys can see what I'm actually pressing the keypad. Where is it? Display. Input display. One. Okay, so on the bottom there now you can see when I'm pressing the gamepad buttons. Okay, so I'm pressing the left button. You can see that that's changing, and that would be the X velocity. So what's interesting is that the X velocity being a value like that is not actually causing it to increment the ship. Let's go back to our trusty calculator. So let's see. So in hex, the value 58 is decimal 88, which is this value in binary. If we were to divide by 4, we get the value 16. So why is it not adding that to my ship's X position? Good question. Let's see. I assume that it is calling the process player loop here. Let's verify that. Okay, so there are the controller updates. I'm looking for my load A and then clear carry. Let's see. Here it is. Let's set a breakpoint, shall we? Is it because of the breakpoint that I just set, or did I do something? Yeah, so it's not hitting that breakpoint. Let's see. Entity type. Compare with player. Branch if equal to process player. Load A. Well, that's weird. It should be. Let's make double sure that I'm definitely. No, that's not the right place. Is it? No, it's not the right place because it's not. It doesn't have those rotates. Okay. Yeah, man, this is just the tedious thing about debugging assembly, right? Is finding your instructions when you want to set breakpoints and that kind of stuff. Here it is. This is the clear carry I was looking for. What's odd, though, is it does still appear not to be calling that code. So let's do a quick check. So it should be calling this, and so it should break. Okay, good. So it breaks on that. So it compares the value of A with 1. Am I doing something where, well, I guess it's possible that I'm not setting. Well, let's do a couple other things also. Let's set the initial velocities to 0. So it is setting the player type to, or the entity type to player. Oh, I know what I'm doing. Pretty straightforward, actually. I am not starting at the beginning of the entity loop. So what I was doing, right, because I wasn't processing the player entity at all in here, I wasn't even bothering to check that one in the loop. So it was starting at the first offset in the entity's memory, completely bypassing the player, which is why it was not doing anything. All right, that makes sense. All right, so let's run. Where are my breakpoints? Let me get rid of these breakpoints. Okay, so let that run. Run. Yes, thank you. And then let's reload that. Okay, so yeah, that's kind of what I expected it to do. It's broken. We can. Yeah, that's pretty cool. So all of this is because of my guess is it has something to do with the way that I'm handling the subtraction of the velocities. Soup 511. What are you making? I am making a shooter for the original NES, and I'm doing that to learn how to make a game on the NES before I start a larger project, which we will get to once we are feeling good about the way the shooter is working. So you can see that it's totally going bananas right now because of the way that I'm handling the velocity. That was interesting, certainly. And I kind of knew that it was going to be busted just because I didn't really think that this would work the way I wanted it to. The question I have is, do shift operations work on negative binary numbers the same way they work on positive binary numbers? And I don't know. I imagine that the answer is probably not, based on the behavior we saw. So let's see. Bit shift negative number. Let's see what we've got here. What is this doing? That's doing something else. That's not what I'm looking for. Yeah. Yeah, I didn't think that that would work, and I'm guessing that we probably will want... Let's try this. Instead of trying to do these bit shifts, let's see if just even doing a simple add will be a little bit more reasonable. And I'm going to stop. I'm not going to process anything on the Y velocity, just because we're not checking to see if it's 0 and not trying to do the decrements in the right way. That's kind of going to be, that's definitely going to be wrong. Let's take a look. Okay, well, it's not going crazy, so that's a good start. Yeah, so I mean, you can already see that's a little bit more like, I mean, that's like actually feeling a little bit more along the lines of what you would expect. It's, I mean, it's super twitchy, right? But it's definitely better than the way it was working before, where it was like a dead stop. If you look at the bottom of the screen here, you can see that when I lift off, it's still, here we can actually even simulate that by slowing the emulation speed down a little bit. So when I press it, you can see, depending on how long I press it for, it continues to move along a little bit. But the thing is, that's too much. That's like super twitchy, and it would be impossible to play the game that way, and you end up scrolling off the screen. So that's why I was trying to do the divide. I was trying to do the divide so that it would be a little bit more smooth, because the ramp up would be less crazy. All right, so I mean, I hate to do this because it's kind of a real lousy approach, but what we could do is we could, for now, until I can find a better approach, we can have a positive, or yeah, a positive x velocity and negative x velocity, right? But I kind of hate that approach. I might have to come back to this. I think I'm going to come back to this next time after I can do a little research of what's the right way to do this, because, you know, I know what I would do in a higher level programming language. You know, you'd use floats, right? You'd use floating point math, and and you'd do your and you'd have the ability to have sign values. So in another programming language, you'd represent the velocity as a vector, right? You have your ship, and you'd have a vector, and it would literally consist of an x and a y value for the velocity, and then you'd apply friction to it, which would decelerate it down till the x and the y velocity are 0. And it would be okay that it would be negative because you're dealing with numbers that can handle it, and you got to deal with some other things to make sure that you're actually getting to 0 when you do you're applying your friction. But the problem is that because we're not using actual floating point values here, or any floating point values here, where'd my stylus go? Because we're not using any floating point values here, and we can't represent negatives, or we can represent negatives, but the problem is that we then have to divide them differently. I think that's going to be the key. I think the key is going to be, I just have to read how to do the bit shift appropriately for a negative number. And honestly, I've never had to do that, because generally whenever I'm doing bit shifts, I'm doing it on positive numbers. I'm not dealing with sign bytes. So I think that's a good starting point. It definitely works a little bit more like what I would expect in a game like this. And let's see. And then we can do the same thing for y, right? We can just super jank, make it just add the y velocity. And now to point out one thing that's good is you notice, right, that it doesn't like start rolling off to the edge when it's supposed to be slowing down. So we did that part right, which is good. If I hold it for too long, it's going to go a little bit bananas, but that's okay too. So let's do sort of the janky implementation of the y direction here, and it's just going to be the same thing as this basically. So the only difference will be that we're dealing with y instead of x, and then when we're done, we just go to we don't actually even need to do that, right? No, we don't need that jump, because that's going to fall right through. Load the y, let's see. Okay, so we're going to load the y velocity, we're going to add the y position, we're going to store the y position, we're going to load the y velocity. If it's equal, we're going to branch to plot. We'll just call this player v done, because at this point we're totally done with velocity. If it's positive, then we want to remove the y velocity, right? And otherwise we're going to add to the y velocity because it's negative, and we're adding y, and this is y velocity, and then this is velocity done. So now at least we should process player v done. Process player v done. Okay, so now at least we'll be able to move up and down as well in the same sort of janky way. Just feel like saying the word janky tonight. I don't know. So it's kind of interesting that it's, whoa, it's behaving differently. Why is it behaving differently? That's kind of cool. Let's see. So that removes the x. We load the y velocity. We clear the carry. If the y velocity, let's see. So that's the other thing. If the y, okay, because we should probably be subtracting. We should be subtracting the y velocity, right? Is that right? because up is moving in the descending y value versus x where it's increasing. So we're going to set the carry, and then we're going to subtract the y position. Right, because again, the top of the screen up here is a lower value than this, so we want to subtract the velocity because our forward is towards the top, and our right, which it moves to the right of the screen, is also positive because of the way that the screen is represented. So I think that's all that was. Let's load that sucker up and see if that fixed it. Oh, whoa, nice. That's pretty cool. I think I'm so now it looks like we have two ships through the magic of flickering. So that obviously didn't work the way that I wanted it to. So okay, so I see. So I reversed what was essentially, okay, let's leave it the way it was, because even though technically the subtract isn't wrong, I'm already doing it in the direction, I'm already doing it in the reverse direction because of the way that the controllers were set up. I don't want to mess with that right now. So to explain, the way that it was working is that if you pressed up on the gamepad, it was subtracting from the y value because it was moving up the screen, and so now it's making the velocity negative, which is fine if you are adding it to the y position so that it moves in a negative direction. Yeah. So then the question becomes, why, though, is it behaving differently than the x counterpart? If it's positive, when we remove, yeah, that's all good. What did I? Let's see. Oh. Am I right? And okay. Yeah, so this is the same problem as before. I just want to add more to it than we're taking away. Why does it seem like the right and left is now even more? Am I updating the wrong values in that? Is that what I did? Even though this is the y, and these yv, y position, store a y position. No, that all looks right. Well, I'm obviously doing something wrong. So let's look at this. So for the x position, we're adding 2 to the velocity. For the y position, we're adding and decrementing 2. So that's consistent. And then we're processing the player, and so we're doing essentially the same thing, right? We're saying, okay, this is the y we're taking the y velocity. Well, this is the x velocity. But down here, we're taking the y velocity. We're clearing the carry. We're adding the y position to it. We're storing it back to the y position. Then we're loading back the y velocity and checking to see if it's 0. Process player view done. So if it's 0, then we're done. If it's positive, then we want to decrement it, right? Yeah, and then if it's positive, and then if it's negative, we want to increment it and jump process player V done. I mean, that all looks good to me. Let's do this. Let's see. Let's see something here. If it's equal, we don't need to do anything because we've hit 0. Otherwise, it's going to remove X or increment X. And then we go to here. Let's remove this for a second and kind of watch the behavior here, because it seems like, okay, so this is as touchy as it was before. This, oh, wait a minute, did I not reassemble it? Yeah, I didn't reassemble it. Okay, so up and down aren't working anymore. Yes, this is not as, this is still pretty, I mean, it's touchy, but it's not as much as it was before. So now, if we, let's do this. So then if we, on the flip side, we just do just the Y value, right? Let's see what the behavior is. Okay, and that's looking more like what I expected it to be with the X and Y together. Right, so now the Y is behaving more of like what I expected it to do. So now when I have both, it should just be the same way. Oh, it is. Well, that's weird. Why wasn't it that way? But I don't know. I'm not sure what I fixed along the way. That's strange. Okay, well, that's more along the lines of what I was hoping to see, and then, like I said, I need to do some investigation on the division of the negative numbers so that we can smooth that out so it's not so crazy fast. The Metal Beast, hey man, don't let me interrupt you, but it's awesome and helpful watching someone work through NES code in real time. Well, thanks for watching. I appreciate that. Let's talk about something real quick that we didn't talk about at all in any of the other streams, which is pretty important. If I can get out of full screen mode. Exit full screen. Yeah, there we go. And that is source control. So do I have source tree on here? I do. Okay, I thought I remembered installing that. So I've created a repository for this source code. And we're going to make a commit because we're at a pretty major milestone in the way that this is working. So right now, the only thing we're tracking in this is this shooter ASM file. And you can use Git from a command line. If you've never worked with source control before, you should familiarize yourself with it if you're going to do any sort of serious programming, because it's a huge, huge help. You don't have to use Git, but you should use something. So what's nice about this is that before we started this whole thing with all the streaming, I had created a repository where I have code that I had written for the way that the game works. And you can see you've got the make file, which is how it's being compiled or assembled, I should say, by Sublime Text. It's calling the make file. I have this Lua file, which is for FCEUX. I've shown it on other streams before, but if you go into FCEUX, where is that folder? If you load this up, you can load up Lua files too. And what this is doing So what this Lua file is doing is it's actually calculating the number of cycles that are being processed between the start of the NMI that occurs at the beginning of the VBlank and the end of my NMI code. So what it's doing is it's if we go to VBlank, and this is just, I mean, I don't expect that we're going to really need this for this project. I mean, who knows, but it's writing a value to 7FF, which is the last address in memory that the CPU can handle for actual RAM built into the system. It's writing the value 2, which essentially starts the process of calculating the cycles, and then all of this code runs, and then when it's done with the NMI code that needs to happen within the VBlank period, it stores that into that same memory address the value 1. If you go back and look at the Lua code, it's actually pretty straightforward. All it's doing is it's registering a callback function. It's saying if the code in the ROM writes to location 7FF in 1 byte length, meaning like I don't care about any bytes after 7FF, which is probably good since that's the last byte you can address anyway. If that 1 byte is written, then call this function calcframes, and then calcframes gets the address that was updated and the size of the address that was updated. In this case, it would be 7FF and 1 every time. And then what I'm doing is I'm reading the value. So if the value is 2, it gets the cycles count on the emulator, I should say. The emulator keeps track of how many CPU cycles have occurred while it's running. So it's getting the last count of CPU cycles, and then when it gets the value of 1, it gets the cycles again, and it calculates the difference, and it writes that difference to the emulator screen. So we can see that we're using between 12 and 1300 cycles for the current VBlank update, which is, fine. And we have something like, I think, 2700 cycles that we can use for our code during the VBlank period in the NMI. And then, so that's what that is. And then here's our actual assembly code. So what's cool about this is now that I've got all of these changes and I'm feeling good about how this all works, I can actually save this off somewhere where it's going to be usable later. And it even has the ability to show me what's changed in my code. So you can see that the player type got changed to the player. We've added these individual bytes. I don't have any external tools hooked up to this yet. There's a bunch of diff tools that you can use to look at the changes a little bit better than in here. Something like Beyond Compare or kdiff3 or whatever. I mean, I'll probably install kdiff3 just because it's the simplest to use. But it's showing all of the different changes that we made to the code over the course of the last what is now 6 streams. So you can see these are all the changes across the source. So what I'm going to do is I'm going to commit this change because we're in a good spot, and I don't want to lose these changes and not be able to revert back if I mess anything up. So got bullet collision with flybys working, as well as terrible ship motion physics. Code in NMI is now in separate loop from NMI, or code in NMI, we'll say game loop code in NMI is now in separate loop from PPU updates in NMI. Right? That's pretty much what we've done over the course of several streams. So I'm going to commit that change. Now when we come back here, we can see that committed change is there. Now I could go into my assembly code and I could do crazy things, right? I could change this file and totally mess it up, and I've just saved that change. So it's actually, if you go to your working copy, you can see it's showing all of this stuff was removed from the file. And if I go, oh man, that's not what I wanted to do, I can discard that change and I'll bring it back to what it was. And you can see we're back to this, where it was before I destroyed the file. Right, we're back to here with our really terrible physics motion and our ships that we can destroy with our bullets. Right, so it's a good place to stop. Anybody have any questions from what they've seen that I haven't answered? Wow, this went on way longer than I expected it to. I didn't expect to do 2 hours. All right, well, thanks for watching tonight, and as I've said before, if you have any questions, feel free to reach out to me on Twitter at Clairvis. If you want to watch the entire video because you missed some of it, you can. I'll be posting the video link to the recording on YouTube here in Twitch. And we'll be back at it again on Monday of next week at 9 Eastern. And catch you next time. All right, thanks for watching.